for January 19th. Let's go ahead and get started. I'm going to embed a question here for you to write down everything you remembered from last semester in math, whether you had me as a teacher or not. Spend about 5 minutes on this. All right. Goal for today is to review concepts from first semester. Why are we doing this? So we can solving equations and understanding inequalities will be very important in our upcoming units on linear equations. So here is a typical problem we saw first semester. You were given an expression with variables, you were given values for those variables, and you were told to simplify by substituting. All right, what we wanted to do here was if we are told that n is equal to 5, then we can replace n with 5 right here and right here. So there's two instances of n, they will both become 5s. And if p is equal to 2, then p can become a 2. And we get a new expression. So instead of n minus, in parentheses, all of this, it's going to be 5 minus, in parentheses, 5 minus 2, close parentheses, all over 2. And now we apply the rules of PEMDAS to simplify this. So PEMDAS tells us what order to do our operations to simplify. The very first thing is P for parentheses. We need to reduce whatever's in parentheses down to a single number. So this is going to become 5 minus 2 becomes a 3. Now that it's a 3 and it can't be simplified anymore, we can drop the parentheses. All right. This big fraction here kind of works as its own parentheses, saying you have to do the whole top and the whole bottom before you can do the division. So we have to do this 5 minus 3, and that's going to become a 2 over 2. And now we can do the division. So 2 divided by 2 becomes a 1. See, earlier on we couldn't do the division because I wasn't sure, am I dividing the 5 by 2? Am I dividing the 3 by 2? But once it's down to a single number, now it's easy to do. Just 2 divided by 2 is 1. All right, here's another one. We'll do this one together. So 3y squared x, and we're going to use x equals 2 and y equals 2. So I'm going to draw an arrow here, showing that the 2 is going to replace the x, and draw an arrow here, showing that this 2 is going to replace the y. Now I've got 3 times 2 squared times 2. Sometimes when I do the substitution, I use parentheses when I substitute. This is really helpful if I have negatives or something like an exponent to just see the clear division of where I substituted in. All right, now I'm going to apply PEMDAS. I do the exponent, so 3 times 4 times 2. And now I'm going to do my multiplication left to right. So 3 times 4 becomes a 12. Keep the times 2. They become a 24. All right, now on to solving. So in solving, I followed, if you can remember that poster on my wall, it's the 6 steps to solving. I'm going to do my best to go through all of those steps on these. The first step is grouping symbols. I look for any parentheses. I don't see them. Next is variables on both sides. Then next is like terms. I do have like terms on the same side that I can combine. The x and the 6x, that can become a 7x. There's an invisible 1 in front of this x that gets combined with that 6 to become a 7. Keep everything else. Then I look for variables on both sides. I want to move the smaller one. I don't have variables on both sides. Then I look for constants on both sides, and then I always want to move away from the variable. So this negative 6 is on the same side as the 7x, so I add 6 to cancel it out. It moves it over to the other side. Now I have 7x equals 7. And then lastly, I get rid of coefficients or divisors. So here I've got a coefficient of 7. I can just divide that away because that 7 is multiplying the x. The inverse operation of multiplication is division. And I get x equals 1. Now that it's an equation, we can double check these by plugging that 1 back in for x and making sure that this balances. So that would become 1 minus 5, or 1 minus 6 is negative 5, plus this would become a 6, so negative 5 plus 6 is a 1, 1 equals 1, and it checks out. All right, how about try this one on your own, and I'll embed a question here for you to tell me what you got. Okay, so what you should have done is combine these. You get negative 10x equals 10. Then you get rid of the coefficient. 10 divided by negative 10, you get x equals negative 1. All right, now these straight line brackets. Let's see if anyone can remember what these are called. These are called absolute value brackets. And what they do is they take the inside and they convert it to being a positive number, regardless if it is positive or negative. If the value is positive, they basically leave it alone. But if it's negative, they multiply it by a -1 and then it becomes positive. So because this quantity contains a variable, we don't know if it's positive or negative. So we need to deal with the two possibilities. In the first possibility, that value is positive, so the brackets can be dropped, and I get 9a plus 7 equals 34. All right, in the second possibility, this value is negative, and it needs to be multiplied by a -1 to become positive again. So I put a negative in front, and the brackets become parentheses. And now I've just got two equations that I need to solve. In this one over here, I move my constants away from the variable by subtracting 7 from both sides. Now I've got 9a equals 27. We'll finish up this side. I'm going to divide both sides by 9. And then get a equals 3. Put a box around that. Over here, I'll get rid of my parentheses by distributing in this negative. And I'll get negative 9a minus 7 equals 34. Then I'll move my constant to the other side by adding 7 to both sides. And I'll get negative 9a equals 41. And then divide both sides by -9. And I get a equals 41 over -9. Plug these back both in to double check. On this side, we'll get 34 equals 34. That checks out. And on this side, that becomes a -41 plus 7. So -34 becomes 34 equals 34. This side checks out as well. All right, another one to try on your own. I'll pause. So I'll embed a question here. Correct answers were k equals 1 and k equals -5/3. All right, now let's talk about graphing single variable inequalities. So the trick is that this is a number line, but it's also going to be a graph of solutions to this inequality. This inequality says x must be less than 3. So I want to represent all of the numbers less than 3. Well, all of those numbers live over here with the boundary right at 3. So I put a dot at 3, and then I ask, does 3 itself count as being less than 3? Well, it doesn't, so I'm going to leave this open. And then I draw an arrow towards the numbers that are less than 3. The trick here is that the end of your arrow should match your inequality symbol as long as the variable's on the left. So there, end of the arrow matches the inequality symbol. We're done with our graph. Here's one for you to try on your own. Sometimes you don't have the number line, so you got to draw it yourself. All right. I won't embed a question here because I can't have you graph. So this is what you should have come up with. With my number line, I always just put the boundary number right in the middle, and then put a few numbers around it. Don't have to go too far. Then I'm going to put a dot at 2. Check and see, is 2 greater than or equal to 2? Well, it is greater than or equal to 2. So if I have that or equal to line, then I want to include my endpoint, and I want to do a solid dot, arrow going off to the right.
Oh my God, Jeffrey.
All right, here's another one for you to try. Let's go ahead and solve this one. It's an inequality, but the steps are still the same to solve it. There's just one small difference when solving these, is if you ever multiply or divide by a negative, you have to flip the direction of your inequality. So to get rid of my parentheses, I distribute in the -8. Then I add 56 to both sides. I get -8n is less than or equal to, this is -8. Here I have to divide both sides by -8, and that activates that special rule. I just divided by a negative, so my inequality flips from being a less than or equal to a greater than or equal to. I've got a 1 on this side. So there's my algebraic solution. Let's do a graphical solution. We'll just make a really short number line here with a closed dot at 1, arrow going to the right, just like that. All right, here, this one's on your own. when you type your answer, you can do just a greater than symbol and then an equals to symbol to represent a greater than or equal to, or if you have to flip it, you could do a less than equal to. But try to type just the algebraic solution to this one. Okay, you should have gotten something that looks like this. B is greater than or equal to negative 17. Just like that would be fine to represent this. All right, now a compound inequality. This has got two inequality symbols. What are we going to do about that? So we've got negative 9 is less than or equal to negative 3n is less than 3. So we are allowed to do an inverse operation to all three sides of this inequality. But I think it's a little bit easier if you split it into two separate inequalities. Make it negative 9 is less than or equal to negative 3n, and negative 3n is less than 3. So I have to repeat that negative 3n in these two different inequalities. Now isolate n in both of these. In this one, I'll divide both sides by negative 3. That activates my special rule. This becomes 3 is greater than or equal to n, or n is less than or equal to 3. And over here, again, I have to divide by negative 3. Activates the special rule. I get n is greater than negative 1. Now when I go to graph this, I'll graph them separately. So close dot at 3, arrow going to the left. But I'll do a very short arrow and I won't finish it until I've done this one. So open dot at 1, arrow going to the right. And we see these two arrows will actually meet up and form a line segment. All right, here's one for you to try on your own. Just type out your answer. Okay, you should have gotten something like this, and here is the graph of that. All right, now we're going to combine it all with an absolute value inequality. So with an absolute value inequality, we still need to split the absolute value into a positive and a negative case, and then graph both sides separately. And we got to remember that special rule. If I ever multiply or divide by a negative, I need to flip my inequality symbol. So I get negative 9 plus x is less than 6, and negative parentheses negative 9 plus x is less than 6. We'll solve this side first. This side we just need to add 9 to both sides. And we get x is less than 15. And over here, I can distribute in that negative. I get 9 minus x is less than 6. Move the constant away from the variable, so subtract 9. Negative x is less than negative 3. And then get rid of the negative by dividing by negative 1. And I get that x is greater than 3. Put a box around that. Now we go to the number line. We're going to graph both of these and see if they connect. So open dot at 15, arrow going left. Open dot at 3, arrow going right. They do connect to make a line segment that looks like this. And because they connect, we often put the word and in between the two answers. If they separated into two rays, we'd put the word or. All right, here's one to try on your own. Just type your solution. You don't have to graph. And we'll say that that is the last absolute value, not equation, but inequality. So that was your last one. I'll be sure to put the answer in for you. But that's that for this video. That's a quick summary of semester 1, and have a good rest of your day.